All right, time for a quick recap of the chapter. The chapter is called the definite integral. We started with the idea of a Riemann sum, and a Riemann sum is very specifically the sum from k equals 1 to n of all of the a sub k's. So this is a1 plus a2 plus a3 plus all the way to a sub n. And then we said, well, let's take that idea and let's talk about some function and let's split the area underneath this function into rectangles. And we'll choose some value of x, could be the middle, the left, or the right, or some random value in some cases. We notice that the height of this rectangle is f of c sub k, and the width of this rectangle will be some delta x sub k. And so then this sum, this Riemann sum of these rectangles becomes the sum from k equals 1 to n of f of c sub k times delta x sub k, noticing the area of that rectangle, base times height. So this sum now is just the area under the curve. We then took this area and we said, well, let's take the limit as these rectangles become infinitesimally small. In other words, we have an infinite number of these rectangles, and the limit of this sum, k equals 1 to n of f of c sub k times delta x sub k, we will define using the notation the integral from a to b, the limits of integration, of the function dx. Remembering that dx is the differential of delta x as that width goes to 0, or the number of rectangles goes to infinity. So notation, b and a are the limits of integration, upper and lower. I think I spelled that wrong. Integration. The R should be over here. Yeah, whatever. We don't care. We know. This is called the integrand, and this is the variable of integration. And I will spell it correctly this time by being careful. There we go. Integration. Yes. So a couple things we figured out is that if we had a constant function, f of x equals some constant, then the integral from a to b of f of x is just the constant, the height of the rectangle, times the difference between the limits of integration. We also looked at something called an accumulator function. And an accumulator function we use when we're piling stuff up. We're accumulating it. And the accumulator function says if we have something piling up at the rate f of t, or by the model f of t, the amount of stuff we have at time x is equal to the integral from when we started at a to time x of the function with respect to time. So again, notice that the function with respect to time would generally start at a and go to some time, we don't know what it is, and x is somewhere in between the limits of t. So you can go back and look at the example that we did in the previous videos if you want more details, but that's just a quick reminder. And finally, where do we find integrals on our calculator? On the TI 8384's math number 9 will give you the definite integral function, and it will either say fn int, and then you've got to type in some stuff, and that's the function, the variable, and your limits of integration, or it will actually give you this. Whoops, that's wrong. Sorry, I did that last bit wrong. I was thinking about derivatives. it will actually give you this, and you get to just fill in the 4 boxes. All right, that's section 6.2. That is the introduction to definite integrals. We'll be back in section 6.3 with some properties of integrals that we can use to start solving some more complicated problems. Thanks for watching. Hope you learned something.